Okay, so in this video we're going to deal with quadratic and rational inequalities. So we're going to look at quadratic inequalities first. So let's just have a little recap on what we would have done so far. So far dealing with quadratics, we would have solved them. Okay, so let's take the quadratic x squared minus 2x minus 8 equals 0. Okay, and your two options, of course, for solving is the minus b formula or to factorize to solve. Okay, so I'm going to jump straight in here and I'm going to factorize to solve this. So I would get x by x, the factors of 8 to make a minus 2 and add it together would be 4 and 2, but the signs would have to be minus 4 plus 2 to add together to make a minus 2x. And so then I would say that x plus 2 equals 0 or x minus 4 equals 0. Take away 2 from both sides here, therefore x is equal to minus 2. Add 4 to both sides here, therefore x is equal to 4. Okay, so now just to recap again then, if I was considering what that function x squared minus 2x minus 8 looks like, okay, if you remember, when you have a positive x squared, you get a U shape. And if when I solve this quadratic, I'm getting the values x is minus 2 and x is 4, then a quick sketch of this quadratic would be a U shape, and it's cutting the x-axis where x is minus 2 and x is 4. Okay, so that's solving quadratics, and that's graphically what that would look like. Your solutions are the roots of the quadratic, or in other words, where the quadratic cuts the x-axis. In other words, at that line there where it's 0. So that's when the function is 0. The result is 0 when you sub in the values x is minus 2 and x is 4. So just to add that note in to bring this all together, so when x is minus 2 in the quadratic x squared minus 2x minus 8, this is a solution into this quadratic. In other words, when x is minus 2, if you sub it in for x, instead of x squared minus 2 squared, instead of minus 2 times x minus 2 times minus 2 minus 8, that all works out to be 0. Hence, it's a solution. Hence, graphically, it is where the quadratic cuts the x-axis. It is at 0 on the y, and that is a solution, therefore, to the quadratic x squared minus 2x minus 8 equals 0. Likewise, when x is 4, if you sub that in to your equation, this will also work out. Instead of x squared, you get 4 squared. Instead of minus 2 times x, you get minus 2 times 4, minus 8 equals 0. And you get, of course, 0 equals 0. Okay, so that's just a little background to it. What we are going to consider now is not an equation, but an inequality. So let's say we have x squared minus 2x minus 8 is greater than or equal to 0. Okay, so we have a quadratic, but it's an inequality. Okay, so if we look back up to our little sketch here, it'll give us a better idea of where this quadratic curve is greater than or equal to 0. We can see here the values of x when the curve is 0 is minus 2 and 4. Greater than 0 then is anything then that is above the 0, okay? So if we look at the graph, the parts of the curve that are above 0 are here and here. Okay, those are the parts of the quadratic that are greater than or equal to 0. Now, which values of x give me those parts of the curve? Well, if I was to consider the value 1, 2, 3, 4, when x is 3, the corresponding y value on the graph is down here. That's not in the section that we want. Over here, likewise, minus 1, the corresponding y value when x is minus 1 is down here on the curve. Again, that's not where I want. So these values in between -2 and 4 give the parts below 0. But, for example, when x is 5, the corresponding y value would be up here. That is in the highlighted part that I want. That part of the curve is greater than or equal to 0. So when x is 5, for example, that would give a result greater than or equal to 0. Likewise, here, when x is -3, it would give a corresponding y value somewhere here, again in the region that we want. So all of the values of x going this way and all of the values of x going this way will give the parts of the curve that are greater than or equal to 0. So my result is x is less than or equal to -2 and x is greater than or equal to 4. It's the parts in between that give the lower part of the curve. In other words, this part of the curve is when it is less than or equal to 0. So just to write that down, x squared minus 2x minus 8. If they had asked me to solve this, where x squared minus 2x minus 8 is less than or equal to 0, that is when I would have wanted the parts below 0. In other words, all of these parts of the curve here. But what are the x values that give this part of the curve? Well, it's all these x values here that are in between -2 and 4. So it's when x is greater than or equal to -2 and when x is less than or equal to 4. Another way of writing that, because it's in between, is when x is greater than or equal to -2 and less than or equal to 4. Okay, so both of those answers are correct. Okay, we're going to take a look at a few of these because I know sometimes pupils find this little idea of the graph sometimes a little bit challenging to digest. And so there's two main ways we can look at this. Whatever inequality you're looking to solve, you're either looking for the x values in between your roots or beyond the roots, okay? So you can just always do a simple little algebraic test either to be sure, are we talking about in between the roots or beyond the roots? So I'm going to look at the following questions in both ways. So if you're finding the graph a little bit hard to digest, hopefully then the algebra might just support your understanding a little bit further. So let's take the following question. X squared minus x minus 6 is greater than or equal to 0. So this is what we're asked to solve. Okay, so the first thing you're going to want to do is draw a little sketch of this, okay? That's our first option here. So we're going to draw a little sketch of this. And in order to draw a little sketch, I want to see where does this quadratic cut the x-axis, okay? So we know straight away because it's a positive x squared, we are talking about a U shape. All right, but where it cuts the x-axis, I'm not sure about. And those are obviously significant points. I need to know, am I talking about in between the roots or beyond the roots for this greater than or equal to 0? And of course, the first thing I need to figure out then is what are the roots? So that means we are first of all going to consider the solutions to this quadratic, okay? In other words, where is this quadratic equal to 0 on the graph, or where this quadratic cuts the x-axis, okay? So they're all different ways of looking at it. So let's solve this quadratic first. Again, you've got two options always with a quadratic. You can use the minus b formula or factorize to solve it. It's a nice simple quadratic, so I'm going to jump straight into factorizing to solve it. X by x will give me the x squared, and factors of 6 to give me a -1 when I add those factors together would be a 3 and a 2. It would have to be a -3 and a +2 to make a -1x, which is what the coefficient of that term is. So solving that further, then I get x plus 2 equals 0, or x minus 3 equals 0. So take away 2 from both sides, I get the result x is equal to -2. Add 3 to both sides, and I get x is equal to 3. So always expecting two solutions, of course, with quadratic. And this is where this quadratic cuts the x-axis. So my little sketch is going to look like this. So minus 2 and 3. And it's a U shape. And I know it's a U shape because it's a positive x squared. If that was a negative x squared, it would be an N shape. Okay, so it's a U shape cutting at minus 2 and 3. So now with your inequality, you're always deciding, is it in between the roots or beyond the roots, okay? So if it's greater than or equal to 0, the parts of the curve I'm looking at, there's 0, that's when it's equal to 0. There's 3 and minus 2, that's where the graph is equal to 0. I want when it's greater than or equal to 0. So it's, again, these parts of the curve here and here. Now, which values for x is going to give you this part of the curve? Is it the values in between? No, the values in between are going to correspond to these values down here. It's going to be the values beyond, okay, just to remind you here, that are going to give you this green region, which is what we want. So it's when x is less than or equal to minus 2, less than minus 2 is all down here, and when x is greater than 3 or equal to 3. We're going to follow, obviously, if it's an equal to sign as well, we'll just include that in our answer. If it wasn't, we wouldn't. Okay, so follow the lead from what the question asks. So it is less than or equal to minus 2 here, and greater than or equal to 3 here. Okay? So again, as I said, if that graph isn't sitting quite well with you, let's have a little look. As I said before, once you figure out what your roots are, so that's obviously always a very important part. You've got to solve it equal to 0 to get what your roots are, to find exactly where it's cutting the x-axis. And then whatever the inequality is, whether it's this way or a less than or equal to 0, whichever way around it is, you're always going to be deciding, right, am I talking about in between the roots or am I talking about beyond the roots? So if you're unsure to work with the graph in order to make that decision, then we're going to fall back on the quadratic itself, okay? So you figure out here that x is minus 2 and x is 3. And we want to solve x squared minus x minus 6 greater than or equal to 0. So maybe we'll check, well, let's try if it's in between the roots or is it beyond the roots? Well, let's take a value that's in between the roots. So between minus 2 and 3, let's say x is equal to, well, 0. 0 is between minus 2 and 3. So let's try that. If x is equal to 0, let's sub it in to my inequality and see does it work. So instead of x, put in 0. And I get minus 6 is greater than or equal to 0. Well, is that a true statement? Does that work? Does that satisfy? Is x equal to 0 going to satisfy that inequality? And no, that doesn't make any sense. Minus 6 is not greater than or equal to 0. So that's not true, which means that's not true. It's not in between the roots. Therefore, it must be beyond the roots. So therefore, it must be less than or equal to minus 2 and greater than or equal to 3. Okay, so that's another way of looking at it, going back to the algebra if you prefer, or maybe that just helps support your understanding of the graph. Either way, two very important things you must remember. Whenever you have a quadratic inequality, you've got to get the roots and either sketch or test. Okay, you either got to sketch and see what's happening to see what's going to solve the inequality, or you've got to test a value to see what is going to solve the inequality. Okay, so let's try this question. X squared plus 3x minus 10 is less than or equal to 0. Press pause, see how you get on with this one. So what you've got to do always is solve it. Let's find out the roots of this quadratic. So it's a nice easy quadratic, so we are going to factorize it. Factors of 10 to make a plus 3 would be 5 and 2, and it would have to be a plus 5 and a minus 2 to make a positive 3. So we have x minus 2 is equal to 0, or x plus 5 is equal to 0. Add 2 to both sides, therefore we get x is equal to 2. or x is equal to minus 5. So there are my roots. Okay, so quick sketch. At 2 and minus 5, so roughly there and there. Okay, and we're talking about less than or equal to 0. There's your 0. So less than or equal to 0 is down here. Okay, so less than or equal to 0 is going to be this part of the graph. So again, it's either going to be in between the roots or beyond the roots. So it's these values here that are going to give the corresponding y values down here on the graph. So from the graph I can see it has got to be in between the roots, therefore greater than or equal to, we'll follow the lead here, minus 5, and these values here less than or equal to 2. Okay, again, if you wanted to do the algebra approach, of course, we would just do a test. So we know we've got 2 and minus 5. Take a value in between. So we'll take x is equal to 0, again, is in between. Let's test if it is in between. So if x is equal to 0, then this should work out. This is what I want to work out. So subbing in 0 is minus 10 is less than or equal to 0. And that is true. Minus 10 is less than or equal to 0. So yes, it is in between. So make sure you write it out then. That means that it's greater than minus 5 and less than or equal to 2. Or another way of writing that, of course, is it is greater than or equal to minus 5 or less than or equal to 2. Okay, try this one. 2x squared minus 5x plus 2 less than 0. Solve that inequality for me now. Pause the video, see how you get on with this. Okay, so this is a little bit more complicated, this particular quadratic. Again, as always, the first thing I'm going to have to do is solve it to find the roots. Okay, so again, you can use the minus b formula, or you can factorize to solve it. I'm going to factorize it to solve it. I'm going to use the 4-step method. So the first number by the last number is 4. Factors of 4 then to make the middle term would be 4 times 1. We would have to have a minus 4 and a minus 1 for them to add together to make a minus 5. And let's just double check that those would also multiply to make a positive 4. And they would. So now we rewrite out the quadratic. And instead of the middle term, we're going to use minus 4x minus 1x. And now we will factorize. Taking these two terms, I can pull out a 2x. And looking at these two terms, I can pull out only a 1. I know that bracket should be the same as that bracket. So what sign would have to go here? It would have to be a minus. Minus 1 times x is minus x. Minus 1 times minus 2 is plus 2. Yes, that works out. Okay, so we have it. So 2x minus 1 go together in the first bracket, and the repeated bracket is the second bracket. So there we go. So solving that then, I got 2x minus 1 equals 0, or x minus 2 equals 0. Add 1 to both sides here, we get 2x is equal to 1, and divide both sides by 2, I get x is equal to a half. And here, add 2 to both sides, I get x is equal to 2. Okay, so there are my roots, and that is always your first step. So now you have two options. You're going to sketch it or you're going to test it, okay? So I'm going to do both, just again to cement the understanding here. So it is a positive x squared, so I know I'm dealing with a U shape. All right, so my values are a half and 2. Just a little sketch. It's going to look like that. Now, again, I'm looking for less than 0 here. So there's 0, and I want less than 0, which is obviously down here. Where is the graph going less than 0 or below the x-axis? And this is the region of the graph that is below 0 or less than 0. So again, your two things that you need to consider: is it between the roots or beyond the roots? Okay, and here we can see we are looking for in between the roots. It's these values of x here between 1/2 and 2 that give the corresponding y values down here on this part of the curve. So it is between 1/2 and 2, in other words, greater than 1/2. Note I'm not putting in or equal to because I don't have or equal to in the question. So always follow the lead from the question. And x is less than 2. Again, that can be written as, of course, greater than 1/2 or less than 2. Okay, so your other option is, if you're not sketching, you've got to test it, okay? So, as I said, I'm going to do both, and it'll hopefully cement your understanding, whichever method you choose. Once you find the roots, that's always your first step. You either sketch or you test. So, I'm going to test, and I'll test then, is it in between? So look at your roots, 1/2 and 2. You know it's either got to be in between or beyond, okay? So we'll test for in between and we'll see is that right. And if it's not right, it must be beyond the roots, okay? So in between the roots, 1/2 and 2 are my two roots. So a value in between those would be 1, okay? So I'm going to test this value that's in between. 1 is the answer. 1 is in between the two roots, so that's the value I'm going to test. So 2x squared minus 5x plus 2, go back to your original inequality, and let's test the value. So subbing in 1 for x, I get 2 minus 5 plus 2 is less than 0, and that works out to be minus 3 plus 2, which is minus 1 is less than 0. That is true. Minus 1 is less than 0. So yes, in between is right. It's in between the roots. So make sure you state what that is. That is then obviously x is greater than 1/2 and x is less than 2. Or in other words, greater than 1/2 or less than 2 in between the roots. Okay, let's have a look at this question. 6 minus x squared greater than or equal to 0. Now, straight away, when you have a negative x squared, you're going to be dealing with an n rather than a u, okay? Because the coefficient of x squared is a minus 1. Okay, now, rather than getting into all the different variations on this with u's and n's, and that can cause quite a lot of confusion, there's an easy thing to sort out with this straight away. What we can do that will not affect the value of x is multiply across the whole thing by a minus 1. All right? And because you're doing that to everything, it's not going to affect the value of x in this inequality. But because, and if you remember from your inequalities with this, because you are multiplying by a negative, there is going to be one change that is going to happen with the sign. So if you remember from just your junior cert solving inequalities, the one big thing that you have to remember is you can solve it like an equation, but if you are multiplying or dividing by a negative, that will cause the inequality sign to flip, okay? So that's the one key thing when solving just linear inequalities, when there's no powers or quadratics to deal with, just normal linear inequalities. You can solve it like an equation, but if you multiply or divide by a negative, it flips the inequality. So the same is true here with this quadratic inequality. If I am going to decide to multiply everything by minus 1, then this is what I will get, but this sign will flip. Now, if I just rewrite this out for myself in a way that I'm more familiar with, that is what I'm left with. And although as a function, this will look different to this, it will not affect the solutions for x, which is what I'm being asked to solve for here. Okay, so a nice way to not have to deal with the n's or worry about trying to solve this when you've got a negative x squared, etc. We can just multiply everything by minus 1. Don't forget to flip the inequality. And now this is something that we're very familiar with in order to solve. So pause the video and see how you get on from here. First step, as always, is to find the roots. So we get x squared plus x minus 6 equals 0. And factorizing this, factors of 6 that would make plus 1 would be 3 and 2, a minus 2 and a plus 3. Okay? So that would be x minus 2 equals 0 or x plus 3 equals 0, which gives x equals 2 or x equals minus 3. Okay, so there's the roots. And there's your sketch. Okay, so once you've got the roots, you're either going to sketch or test. I'm going to sketch first and I will test. You only need to do one, whatever sits more comfortably with you. So we are looking for less than or equal to 0. So where is the graph less than or equal to 0? It's less than or equal to 0 down here. That's below the 0. So are we talking about in between or beyond? And we can see quite clearly all the values here in between minus 3 and 2 will give the corresponding values down here below 0 on the quadratic curve. Okay, so it's in between. So in other words, x has got to be greater than minus 3 or equal to, I'll follow the lead from the question, or less than or equal to 2. So greater than or equal to minus 3. You can write it like this. You don't have to write it all together, and less than or equal to 2. So both of those answers, whichever way you're comfortable with giving it. So that is the answer, and that is it if you're sketching. If you're going to go down the testing route instead, then again you get your solution 2 and 3, and we test for in between. So what is between 2 and minus 3? So x 0 is a nice easy result we could test with. So again, going back to your inequality that we're working with. So if x is 0, then we get minus 6 is less than or equal to 0. And that is true. So therefore, yes, it is in between the roots. So state what that is. That means it's got to be greater than or equal to minus 3. And it's got to be less than or equal to 2. Okay, so if you're at all confused then by what we did up here by multiplying by minus 1, you can see if you want to go and test back with our original, we are saying it's in between the roots, okay? And as I said, the graph of this would be an n. It would still have the same roots, so it would still be cutting at minus 3 and 2. Okay, but of course where it is greater than or equal to 0 is up here between the roots. And again, if you were to test, a value in between the roots would be 0. 6 minus 0 minus 0 squared is greater than or equal to 0. That is also true. So you see the way by multiplying by minus 1, it changes the inequality to something we're more used to, but it does not affect the value of x at all, because that would be the function graphed. A negative x squared would be an n shape. If we're talking about greater than or equal to 0, it's still going to be the upper part, in other words, between the roots. And if I test the value between the roots, that is still also going to work out to be true. So it doesn't matter that you've decided to do a multiplying by minus 1 to flip the inequality. The results are still going to be the same, but this is something that you're more used to. So you might find it much easier to keep it like that and test it in that form. Okay, so last question before we move on to rational inequalities, which are going to be very similar. But before we do, we want to just make sure we're cementing our understanding of the quadratic inequalities. And so let's have a look at this last example. Pause the video and see how you get on with this. So again, we have this negative x squared, and I don't want to get into dealing with that. So what I'm going to do is I'm going to multiply everything by minus 1. And so I get minus 12 plus 5x plus 2x squared. And of course, because I'm multiplying by a negative, it flips the inequality sign. Okay, so that then gives me 2x squared plus 5x minus 12 is less than 0. That's what I'm looking to solve. So the first thing I've got to do, as always, is consider what the roots are. So put it equal to 0 and let's solve for the roots. So I'm going to do my 4-step factorizing method, 2 times minus 12 is a minus 24. I want factors of minus 24 then. That will give me a plus 5. And factors would be 8 and 3. It would have to be a positive 8, take away 3 to get a plus 5. And let's just double check, do these multiply to make a minus 24? And they do, so I know I have my signs correct and my factors correct. So rewriting the quadratic, I have 2x squared plus 8x minus 3x minus 12 equals 0. Pulling out what's common to these two terms, I can pull out the 2x and put a plus 4. Common to 3x and 12, I can pull out a 3. I always leave that sign till the end. I know these two brackets have got to be the same, x plus 4. So let's see what sign would make this work. To get a minus 3x back again, by multiplying 3 by x, I would have to get a minus here. And let's check what I get a minus 12. Minus 3 times plus 4 is minus 12. So yes, that works. So we get 2x minus 3 in one bracket, and the repeated bracket is x plus 4, the second bracket. So that gives you 2x minus 3 equals 0, or x plus 4 equals 0. So add 3 to both sides here. We get 2x is equal to 3. Divide both sides by 2. And I get x is equal to 3 over 2. And there's my first root. And x plus 4 equals 0. Take away 4 from both sides. And I get x is equal to minus 4. And there's my other root. Okay, so my options are to sketch or to test. So I'm going to sketch first. And then I'll test it to show you both methods. So x is equal to minus 4 or 3 over 2 or 1.5. And of course, it's a U curve. So we're talking about 2x squared plus 5x minus 12. So that's a positive x squared. So therefore a U. And I want to consider then when is it less than 0, okay? And of course there's 0. So when is it less than 0? So less than 0, is it in between the roots or beyond the roots? Beyond the roots, just to recap, would be this section and this section, or is it in between the roots? So I want the part of the curve that is less than 0, which is that. That's the quadratic part that is less than 0. What are the x values then that give that part of the curve? Well, it's all these values here in between that will give the corresponding values on the curve down here. These values of x in between give the values on the curve down here below 0. So it is between minus 4 and 3 over 2. In other words, greater than minus 4 and less than 3 over 2. In other words, greater than minus 4 and less than 3 over 2. Again, either way you want to write that is correct. So that's sketching, or if you prefer to test it, again, you've got your two roots. You've got x equals 1.5 and x equals minus 4. And let's say we're going to test in between. So we consider a value in between 1.5 and minus 4. So 0's in between. Let's test that nice easy value. So going back to 2x squared plus 5x minus 12 less than 0, we are testing the value x equals 0. So 2 times 0 squared plus 5 times 0 minus 12. That would give minus 12 is less than 0, which is true. So yes, it is in between the roots. And so writing down what that actually is, of course, that is greater than minus 4 and less than 3 over 2. That is in between the roots. Okay, so now taking a look at rational inequalities. Well, what's a rational inequality? Well, basically, a rational function is when you have a polynomial on the top and the bottom. Okay, so f of x is equal to 3x minus 2 over x plus 1. So that would be the function. So this as an inequality would be when you're asking maybe to solve this. Okay, so this is a rational inequality because you have this fraction. Okay, so your first thought might be, if you were dealing here, you see, with an equation, and the minute you have any sort of denominator, your first instinct is always to, let's get rid of the denominator. And let's get rid of the denominator by multiplying across by the denominator. So a lot of pupils' first instinct with this is to go, well, I'll multiply both sides by x plus 1. So let's say you multiply this side by x plus 1 and you multiply this side by x plus 1. Okay, now what's nice about that is then that would cancel with that. Okay, and then you'll be able to solve. Except there's one big issue here, and that is the very same issue as I talked about in the last section. If you remember back from your junior cert linear inequalities, yes, you can solve them like an equation, but there's one thing you have to remember, and that is if you are multiplying or dividing by a negative, it will cause that inequality sign to flip. Now, what did we multiply? We multiplied by x plus 1. And the issue with multiplying by x plus 1 is we don't know whether that is a positive or negative. Because we don't know what the value of x is, let's say x was minus 5. Well, that would make x plus 1 to be minus 4. And therefore, you'd be multiplying across both sides by minus 4, in which case you would have to flip the inequality. So that's an issue. But if x was 5, then you'd be multiplying by x plus 1, which would be 6. So you'd be multiplying both sides by 6, in which case you wouldn't have to flip the inequality. So here's the predicament. Yes, you're going to want to multiply by the denominator in order to get rid of the denominator, because you can't be dealing with the denominator in solving this. However, we can't be sure whether or not to flip the inequality because we don't yet know the value for x. So what do we do? Well, here's what we do. We consider multiplying by something that is going to get rid of that denominator, but also something we know for sure isn't going to flip the inequality. So what we do is we take whatever the denominator is and square it. And make sure you multiply by both sides the x plus 1, which in this case is the denominator, and square it. So x plus 1 squared is what I'm going to multiply to both sides. So what that allows me to do is x plus 1 is going to cancel into one of those. So it will get rid of the denominator. So what I'm left with on the left hand side is x plus 1 by 3x minus 2. And on the right hand side, I'm left with 2 times, and of course, x plus 1 squared is square the first, square the second, and double the product of the two. X plus 1 all to be squared is x squared plus 2x plus 1. X plus 1 by x plus 1, in other words. So just to clarify, the reason we are multiplying by x plus 1 all to be squared is because no matter what value this x plus 1 works out to be, even if the x is a minus 5 as we suggested, and then x plus 1 works out to be minus 4, the minute you square it, even if it is a negative in this bracket, the minute you square it, it is of course a positive value. So by multiplying by x plus 1 squared, we know it won't flip the inequality because you're multiplying by something for sure is positive. Regardless of what that x value works out to be, the minute you square the whole thing, it has to then be positive. So by multiplying by x plus 1 all to be squared, we're definitely multiplying by something that's positive, in which case we know for sure that inequality sign won't be flipped. And now it's a matter of solving this. So I have x times 3x minus 2 plus 1 times 3x minus 2, and multiplying in by the 2 here, I get 4x plus 2. That gives me 3x squared minus 2x when I multiply in by the x here, and 3x minus 2 here. Tidying up, I get 3x squared plus x minus 2. And now I can tidy it up even further. I'll take away 2x squared from both sides here, and I'll get x squared plus x minus 2 is greater than or equal to 4x plus 2. Take away 4x on both sides here, and of course I'll end up with x squared minus 3x minus 2, and that's gone. It's equal to 2, and take away 2 on both sides, of course, will give me x squared minus 3x minus 4 is greater than or equal to 0. And now I am left with a quadratic inequality. So for my quadratic inequality, remember what you've got to do. You've got to find the roots first. So we'll solve it to find the roots, and then you either sketch or test. So finding the roots, I get minus 4 plus 1. That gives me x plus 1 equals 0, or x minus 4 equals 0. So x is minus 1, or x is equal to 4. It is a U-shaped, so if I was sketching, I'll get minus 1 and 4. I want when it's greater than or equal to 0, so I am looking for this part of the curve. And therefore, it's going to be these values beyond minus 1 and 4, so less than minus 1 or equal to, follow the lead from the question, and greater than or equal to 4, that's beyond the values minus 1 and 4. If you were testing it and we wanted to test in between just to see if that was going to work, in between the roots, a value in between the roots would be x is 0. So if you were testing x is 0 back into your inequality, putting 0 in for x, we get, of course, minus 4 is greater than or equal to 0, which we know is not true. Therefore, it is not in between the roots, so it must be beyond the roots. Okay, and you must write down what that is. Then, of course, x is less than or equal to minus 1 or greater than or equal to 4. Okay, so try this rational inequality. Okay, pause the video and see how you get on with this. Right, so again, what we need to make sure of, we want to get rid of the denominator, but we mustn't flip the inequality. So to make sure we do that is we'll multiply by that denominator squared. And that will cancel with one of those. And so what I'm left with is x plus 2 by x plus 3 and 2 times x plus 2 squared. Okay, so that gives me, multiplying this out, that expansion on the left hand side, and x plus 2 all to be squared, square the first, square the second, double the product of the two, is x squared plus 4x plus 4. If you need to do it the long way out, x plus 2 by x plus 2, by all means do that, but just make sure you've got that middle term. Make sure you've expanded that correctly. So x by x here is x squared, multiplied by 3x, 2x plus 6, and multiplying by 2, we get 8x plus 8. So tidying up my left-hand side, I get 5x plus 6 less than 2x squared plus 8x plus 8. And tidying up further, I'm going to bring everything over to the left-hand side, or subtract this left-hand side, and what I would get is take away x squared, and I would get x squared, take away 5x, and I'm going to get 3x, taking away the 5x from 8x, and 6 from 8, of course, is 2. So this is the quadratic inequality I'm now left with. And obviously with a quadratic inequality, I know my first thing is to solve for the roots. And so solving that, I get x times x, 2 times 1, plus and plus. So I get x plus 1 equals 0, or x plus 2 equals 0. That gives me x equals minus 1, or x equals minus 2. So there are my roots, and now I'm going to sketch or test. So sketching gives me, it's obviously positive x squared, so here we go, and minus 1 and minus 2. I want where it is greater than 0. So you see, this is the part of the curve that is greater than 0. So where is it greater than 0? It's greater than 0 here and here. So again, I want the x values beyond the roots. You know, it's always either going to be beyond or between. So it's not in between. In between would give the part of the curve down here below the x-axis. I don't want that part. I want the part that is greater than, see the big bit is by the function, the greater than 0. So I want these bits up here. So x is less than minus 2 and x is greater than minus 1. Okay, and if we are testing, so maybe we take the test and go again in between. Let's test if it's in between the roots. So the two roots are minus 1 and 2, so a value in between would be minus 1.5. So testing that value minus 1.5 into the inequality would be minus 1.5 squared plus 3 times minus 1.5 plus 2. Is that greater than 0? And that works out to be minus 0.25. Greater than 0, that's not true, which means it's not in between, it must be beyond. And therefore that is less than minus 2 and greater than minus 1. Okay, so final question. Solve the following rational inequality. So they often stipulate, and they have here, I didn't put it in the last couple of questions, but they'll just stipulate that x is not equal to minus 3. All that is letting you know is the value for x can't be minus 3 because that would make the denominator 0. So to make this inequality valid, you can never divide by 0, you see. So that's why they have that in here. So you can't divide by 0, that's why the value can't be minus 3. So it's just in there, not really telling you anything other than it's the only thing that makes this valid is for them to state that x is not equal to minus 3. Okay, so don't worry about it apart from that. All right, so taking this rational inequality, our last example, pause the video, let's see how you get on with this. Okay, so what we're going to do is we want to obviously get rid of that denominator, but to make sure I don't have to flip the inequality sign, I'm going to multiply by x plus 3 squared. And just to clarify, the reason, of course, I'm multiplying by x plus 3 squared is because no matter what this then is, this value in here, once you square it, you know for sure it's positive. So that's why I never have to worry about flipping that inequality. Okay? X plus 3 squared, no matter if that inside the bracket works out to be a negative or not, the minute you square something, it's always going to give a positive result. So that's why we know for sure when we multiply by x plus 3 all to be squared, that we're multiplying by something that's positive. Hence, the inequality sign doesn't flip. So what that allows us to do is get rid of that denominator. It will divide into one of those, okay, because you've got x plus 3 times x plus 3 because it's squared. So you have two of them being multiplied. So when you divide one into one of them, we get x plus 3 left. So on the left-hand side, we have x plus 3 by 2x minus 1 and 3 times x plus 3 all to be squared. Okay, so let's multiply this out. Take your time with this. Don't try and do too many things in one go because there's a lot of multiplying out here. Squaring x plus 3, square the first, square the last, double the product of the two will give me that. Of course, multiplying x plus 3 by x plus 3, be careful, make sure you get the third term. So we end up then with 2x squared minus x plus 6x minus 3 and 3x squared plus 18x plus 27. Tidying this up, then I get 2x squared plus 5x minus 3 is greater than 3x squared plus 18x plus 27. All right, let's take away everything here on the left hand side. So we have it all tidied up. So taking away 2x squared from both sides, 3x squared, take away 2x squared then is 1x squared. Taking away 5x from 18x will give me 13x, and adding 3 to both sides here will give me 30. So this is the quadratic inequality I'm then left with, and that's what I'm now going to solve. So as always, find the roots first. It is less than 0, okay? You see the quadratic has the smaller side, so make sure if you're rewriting it out, the quadratic will still have the smaller side facing it. So solving, of course, this first to get the roots, I'm going to factorize, and I get 10 and 3 plus and plus. So I have x plus 3 equals 0 or x plus 10 equals 0. So x is equal to minus 3 or x is equal to minus 10. Okay, so I'm going to either sketch or test. I'll do both. So minus 3 and minus 10, it's a U shape, of course, and I want when it's less than 0. So let's say that's minus 3 and that's minus 10. I want when it is less than 0, so it is less than 0 down here. In other words, it's going to be these values in between that give the corresponding y values down here on this lower part of the curve below the x-axis. So it is when x is greater than minus 10 and less than minus 3. In other words, greater than minus 10 and less than 3. So that's the answer. If you were testing it as your method to see the solution to this quadratic, we would look at minus 3 and 10. Let's test a value in between. So is it in between? So let's test a value in between minus 3 and minus 10. So I'm going to test minus 5. So subbing it back into my original quadratic then to see if it is in fact less than 0. Minus 5 squared plus 13 minus 5 plus 30. Is that less than 0? And it is minus 10, which is of course less than 0, which means yes, it is in between the roots. That means x is greater than minus 10 and less than minus 3, just as above.